Alright, in this lesson we're going to be learning about parabolas, and for right now the parabolas, we're going to keep their vertices at the origin, and in the next lesson we'll move off of the origin. So please remember that whenever you first learned about parabolas, you probably learned y equals x squared, and they showed you what that looked like, and it looked something like this. Alright, so that's y equals x squared. And we saw that if we made it negative x squared, then it was going to look like this. So that turned it upside down. Alright, now, so just I want you to hold that in the front of your mind. That's what it looks like when we have y equals x squared. Now, please understand that in the models we're going to be doing today, we're going to be looking at the equation written around in the other direction, more like x squared equals y. But that's still the same thing, okay? It's still the same thing. Now, if you ever see an equation that has the y squared instead of this normal x squared like we're used to, if you see one that has y squared equals x, all right, how would we even put this in the calculator? You know what I mean? If you go to enter an equation, it already has y equals, and so you could put in x squared. But if you saw y squared, how would you even put this in the calculator? If you see something weird like this, that means it's sideways. All right, it's either leftward facing or rightward facing. Okay, so that's the first thing you have to do as you look at these equations, is decide, is it going to be up, down, left, or right? Okay, so looking at this equation, if I sort of read it from right to left, I see that I've got y equals x squared. All right, that's normal. So that would either be up or down. Now, because of the negative involved, I know that this one's going to be facing down. And let's just go through and do that for all of them real quick. No, I guess I better not. So in case somebody just only watches one problem at a time. So this one is going to be a downward facing parabola. So go ahead, and we're just doing a quick sketch. So we're just going to go like this. All right, put some axes on here. So we know this is facing down. Now, another thing that you need to understand, when you look at the model for a parabola, it's going to be x squared equals 4p times y. We have to get the x squared by itself. So let me zoom in a little bit. Whoops. I need to divide both sides by 3. Get that out of there. So if I divide both sides by 3, okay, put that little invisible 1 there. So this will be like having x squared equals negative 1/3 y. Okay, now look, whatever's in front of the y here, that equals 4p. So for this problem, 4p equals negative 1/3. So I have to find out what p is. So I would divide both sides by 4. Okay. Now, if I do negative 1/3 divided by 4, okay, negative 1/3 divided by 4, or however you want to do it, I'm going to get, wasn't fitting on my screen here, I'm going to get negative 1/12. So what's happening is that 4 is really just multiplying the denominator. So it's going to be negative 1/12. Okay, so that's my p value. So p is negative 1/12. Now we knew this would be down. The p value tells you how far down your focus is going to be. So here's my focus, okay? So this has to be 1/12 of the way down. So that tells me that this is going to be 0, negative 1/12. Okay, we know the directrix has to be this horizontal line in the opposite direction. So the directrix will be up here. And again, this distance has to be 1/12. So, whoops, 1/12. All right, it's 1/12 in both directions because that's always p. So this is going to be the equation y equals 1/12. That's my directrix. So all of these equations today are going to be at the origin. The vertex will be at the origin. Okay, so we're just doing a rough sketch, so that's all you need for a rough sketch. Okay, so that's it. By the way, so like I said, this is the general model when it's at the origin. The vertex is at the origin like this is. In the next lesson, you're going to be seeing equations that look more like this. Like, for example, x minus 3 squared is equal to 12 times y minus, in fact, let's say y plus 5. When we do these in the next lesson, the vertex, just like when we used to do the center of a circle, the vertex will be the opposite of these. So the vertex would be 3, negative 5. All right? But if the vertex is 0, 0, okay, then this all goes away and it just becomes x squared and y. Okay, so if you just see x squared and y, you know that the vertex is at 0, 0. So, number 2. First, you have to decide, is this up, down, left, or right? What do you think? Well, first of all, I see x equals y squared. That's weird. We're used to having y equals x squared. This is normal. Okay, that would be a normal, I don't know why I drew y just then. This would be a normal parabola. But having the x squared, and having the y squared instead, that tells us that's going to be sideways. Okay, let me erase some of this mess. So this is a sideways parabola. Since I don't see any negative signs, I know that it's going to be to the right. Okay, that's the first thing you have to decide. So this is going to be going to the right. So it's going to be somewhere. It's going to be doing this type of a thing. Okay, now I need to know what the values are. Wait, back on number 1. We have to list everything. So the vertex was 0, 0. The directrix was y equals 1/12. And the focus was 0, negative 1/12. Now, so on number 2, to get the rest, I need to know what the p value is. So we have to get y squared by itself. So let's divide both sides by 2. Put an invisible 1 right there. So that tells us that y squared is equal to 1/2 x. Okay, so this must be our 4p. Okay, so 4p is equal to 1/2. If I divide both sides by 4, okay, that's going to give me p equals 1/8. All right, this is just going to wind up multiplying by that, so I get 1/8. So this is going to the right, so that means my focus is going to be right here. But remember, this distance is my p value, so that's going to be 1/8. Now if I go the other direction, 1/8, that's going to be my directrix. So my directrix is going to be like right here. And again, this should be 1/8. Okay, so this point is going to be 1/8, 0. So that's my focus. All right, of course the vertex is 0, 0. So my focus is 1/8, 0. And the directrix is a vertical line to the left 1/8. So that's going to be x equals negative 1/8. Alright, so that's it for that one. Alright, looking at number 3. Is this going to be up, down, left, or right? Well, this one's going to be up. Okay, ignoring the 8 for a second. Y equals x squared. That's normal. Alright, that's what we learned in the first place. And since everything is positive, I know it will be up. So we might as well just start that off with my quick sketch. So we know it's going to be this type of a parabola, upward facing. Okay, now we need the p value though. Okay, so I know that the number in front of the y here, that's 4p. So 4p is equal to 8. So if I divide both sides by 4, that means p is equal to 2. Okay, so that means if I go up 2, then that's going to be my focus. So that's 0, 2. If I go down 2, that should be my directrix. Okay, is there anything else I need? So the vertex is still going to be at 0, 0. And then my directrix is right here at y equals negative 2. Alright, so like I said, my focus was 0, 2. Alright, so that is it for number 3. Alright, looking at number 4. Is this going to be up and down, or is it going to be one of those sideways ones? Yeah, this one's going to be sideways, alright? So just ignore the negative 10 for a second. X equals y squared. That's not normal. Alright, so we know it's going to be sideways. Because it's negative, it will be to the left. So as we do our quick sketch, we know the parabola is going to be facing to the left like this. Okay, now we need to know what that p value is. Now, whatever's in front of the x here, that's 4p. So we know that 4p is equal to negative 10. So I'm dividing both sides by 4. That means p is equal to negative, let's see, so negative 5 over 2. I should probably show it. I'm dividing by 4. And see, there I just reduced. This 10 over 4 reduces down to 5 over 2. Now, it would be helpful to have the decimal version, alright? So p is equal to negative 2.5. Okay, so that means the focus is going to be over here. So say if this was 1, 2, 3, alright, the focus would be right here. So this is going to be negative 5 over 2, 0. That's my focus. And meanwhile, the directrix would be right through here, alright, at positive 2.5. So this is the equation x equals 2.5 because it's a vertical line. And that's all we need for the sketch, but we should record that information. Alright, of course the vertex is still here at 0, 0. The directrix is x equals 2.5. And the focus was negative 5 over 2, 0. Alright, let's look at number 5. First you have to ask yourself, is this one going to be right side up or kind of sideways? Alright, well, ignoring the negative 16 for a second, you see this is like having x equals y squared. That's totally weird, alright? We're used to having y equals x squared, so we have the wrong variable squared. So we know this is going to be one of those sideways ones. And because it's negative, that means it will be to the left. Okay, so that's crucial. So as you do your rough sketch, all right, you know it's going to be facing to the left like this. Okay, now we just need to know what the p value is. All right, but this is 4p, right? So that means 4p is equal to negative 16, which means that p is equal to negative 4. So 1, 2, 3, 4. All right, there will be our p value. So that means the focus is negative 4, comma 0. All right, 0, comma 0, negative 4, comma 0. The directrix goes in the opposite direction, so 1, 2, 3, 4. So the directrix will be right here. Okay. Vertical lines have equations x equals a number, so the directrix will be x equals 4. All right. So that was it for number 5. All right, and number 6. Will this be up, down, left, or right? All right, I'm hoping that you said down. It will be down. All right, ignoring the negative 36 for a second, we have y equals x squared. That's a nice normal graph. We could put that right in our calculator if we wanted to. You know, as opposed to number 5 over here, how would you put that in your calculator? Okay, so the ones that you couldn't put in your calculator without taking a square root or something, those are the sideways ones. So this one's right side up. The negative makes it down. Okay, yeah, anyways, this is our 4p. Well, let me do the sketch first. So I know it's going to be downward facing, so it's going to be doing this type of a deal. Okay, now the 4p has to equal negative 36. That means p must equal negative 9. So that tells me 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so my directrix is y equals 9. And my focus is 0, comma, negative 9. All right, of course, the vertex is still 0, comma 0. Okay, so that is our quick sketch for number 6. All right. So now we're going to have to add in one more detail to more accurately sketch the graph. It's still going to start off the same way, though. Is this going to be up, down, left, or right? This one's going to be facing to the right. Okay, I see x equals y squared. That's not normal, so I know this is sideways. Positive means it'll be to the right, so I'm expecting it to be kind of like this. I have to be more precise than that this time, though. So let's find that p value. So I know that 4p is going to equal this 8, all right, the thing in front of the x. That means p is equal to 2, okay, when I divide. Now I already knew it was going to go to the right, so there's my focus. All right, are they having us list that stuff this time? So I already know my focus is 2, comma 0. All right, I already know the directrix will be on the opposite side. Okay, so that is x equals negative 2. All right, the vertex is still 0, comma 0. All right, now to make the graph, though, this time I can't just sketch it any old way I want. We have to use what we call the focal width. All right, let me just write that down one time. Focal width. All right, the focal width is going to come from this 8. All right, ignoring any negative signs that show up, this is the focal width. All right, that means at the focus here, the width of my parabola has to be a total of 8. So watch this. So that means I have to go up 4 and down 4. All right, so I have a total width of 8. So this is my vertex as usual. So if I draw my graph using these points, then it's going to be more accurate. All right, so notice at the focus, the width is 8. All right, and that's what this number tells me. All right, let's take a look at number 8. So is this up, down, left, or right? This one will be down. Okay, ignoring the negative 12 for a second, I have y equals x squared. All right, that seems normal to me. Y equals x squared is what we first learned about. Now, the fact that it's got this negative in it means it'll be a downward facing one, but it won't be sideways. So keep that in mind. Now let's find that p value. So I know that 4p is going to equal that negative 12 right there. So if I divide by 4, I get p is equal to negative 3. All right, so that I already know it's going to be down, so I'm going to go down my 3, and there's my focus. So right there I know the focus is 0, negative 3. Now the directrix should be the same amount in the opposite direction. All right, it's horizontal, so it's y equals 3. Now, for now, the vertex is still at 0, 0. Okay? So now we need to use the focal width to get a couple more points here. Now remember, the focal width is going to come from this number in front. All right, but it's the absolute value, so ignore the negative sign. So the focal width is 12. So that means right here at this level, it should be 12 wide. So that means 6 in each direction. So at the focus, if I go over 6 to the left and right, then that should give me another pair of points. So I will be sure to include that when I draw my parabola. So it'll look like that. Okay. All right, just a couple more. So look at number 9. Will this one be up, down, left, or right? This one is going to be to the left. All right, ignoring the negative 16 for a minute, I see x equals y squared. That's weird. All right, this has to be sideways. A normal graph would be like y equals x squared, which written in this way would be like x squared equals y. So if the x is squared like normal, that's up, down. But if the y is squared, that's sideways. And the fact that I have a negative number here means it's sideways to the left. Okay, now let's figure out what the p value is. So I know 4p has to equal this negative 16. If I divide by 4, I'm going to get p equals negative 4. So I already knew it's to the left. So there's my focus right here. That is the point negative 4, 0. All right, the directrix should be in the opposite direction. Okay, so the directrix should be this line right here. Vertical lines are always x equals something, so that'll be x equals 4. All right, we're still doing vertex of 0, 0. So all we need now is the focal width. All right, I guess I'll just do it here. The focal width is going to be 16. It's just the absolute value of this. So that means the width of the parabola is 16. So that means 8 up and 8 down for a total of 16. Okay, and my vertex is at 0, 0. So that means my parabola is doing this type of a thing. Okay. Alright, I think this is the last one. Alright, so number 10. For some reason they flipped this around backwards, so the new model that we're using is x squared equals 4p times y. So this is how all the rest of them will be. So let's go ahead and keep the squared term on the left by itself. Okay, so anyway, is this going to be up, down, left, or right? This one's going to be up, upward facing. All right, ignoring the 2, I have y equals x squared. That's a normal parabola. So it's going to be up. Now the 4p is going to equal 2. So if I divide both sides by 4, maybe I'll show it this time. Then I'm going to get p is equal to 1/2. Okay, so that's very tiny, but I got to deal with it. Maybe I'll zoom in to help me out a little bit. Yeah, so I decided that p is equal to 1/2. Okay, so and remember, I'm going up. So if the p is at 1/2, that means the focus is going to be literally half of a square up. Okay, so that is 0, 1/2. So that's the focus. So we can write that down. Alright, now the directrix should be in the opposite direction. Okay, so the directrix is going to be like right here at -1/2. Alright, I feel like I didn't put enough dots in there. Alright, but anyway, the directrix. Horizontal lines are always y equals, so this will be y equals -1/2. Alright, vertex is still 0, 0 for today. Okay, now we need those 2 more dots, so we will need the focal width. Alright, now the focal width is going to come from this number right here. So my focal width is 2. Okay, so that means here at the focus, the width has to be a total of 2. So that means 1 to the left and 1 to the right. And of course the vertex was 0, 0. So this is just a tiny little parabola thing. So it's going to start off like that. By the way, don't let your parabola stop short. Okay, you need to go ahead and continue it all the way to the edge. Okay, so the rest of the graph would look something like that, but at least we have those values. Alright, as long as this is the last problem anyway, let's go ahead and use the calculator to help us get some more values, because I feel like we're really just guessing too much on this one. Alright, so let's look at our calculator. How could I put this in my calculator to get more values? Well, wouldn't I have to divide by 2? Okay, that's not what I would do to find p. This is the way to do it. But if I wanted to get a table of values, of course I'd have to get y by itself. So this is like x squared over 2, or 1/2 x squared. So let's see. So I'll just do x squared over 2. Whoa. X squared over 2. Okay, so I'm just going to scroll and see how many will fit. So that's too far. So at -4, I'm at 8. Let me see what I can do here. Okay, so at -4, we're at 8. So it'd be right there. All right, and parabolas are symmetric. So if I have a point here, 4 to the left, I'm going to have another one here, 4 to the right. See what else I have. At -3, I'm at 9 halves, which as a decimal is 4.5. So -3 is 4.5. So -3 and 4.5. So again, there should be another point mirror image. Anything else? At -2, we're at 2. So that puts me here and here. And we already know that at -1, we're at 1/2. And then there's your origin 0, 0. So that gives us a much more accurate picture. So when you want total accuracy, if you're allowed to use your TI-30, that's what you should do. Okay, so that's going to give us a more accurate graph. Alright, and that is the end of this lesson. Okay, that was number 10. I hope it was helpful, and I will see you on the next video.